Section 1.6 Rational Expressions. So we're going to talk about rational expressions in this section and what we can do with them. So let's first start by defining what a rational expression is. A rational expression, if you recall, I mentioned earlier, rational is just a fancy word for fraction. So a rational expression is a fraction with a polynomial in the numerator and in the denominator. So that's what it is, where you have a polynomial in the numerator and denominator. So let me give you some examples of rational expressions. Okay, it'd be something like this: 3x plus 1 over x squared minus 3. That's a rational expression. Or you could have x squared plus 2x plus 4 divided by x cubed plus x. Those are rational expressions. Okay, where you have a polynomial on the top, polynomial on the bottom, polynomial on the top, polynomial on the bottom. So what we want to do is some basic algebra with these rational expressions. The first thing we want to do is we want to learn to multiply and divide rational expressions. So let's go ahead and take a look at that, how we go about doing that. This is pretty much exactly the same as multiplying and dividing fractions. So this is, let me write down, similar to multiplying and dividing fractions. And when I say fractions, I'm talking about regular fractions with numbers. So how do we do that? We basically cancel common factors from the numerator and the denominator. That's what we do. So when we are multiplying and dividing fractions, we basically cancel the common factors from the top and bottom. Okay, so let's take a look at how we go about doing this with rational expressions, since it's similar to that. Before I go further, let me just point this out to you. If you're dividing two fractions, this is just something you've done before. If I'm dividing two fractions where a, b, c, and d are just some numbers, what do we do from basic algebra? We change the division to multiplication, correct? And we flip that second fraction, so we get d over c. So this is what we do when we divide two polynomials. Okay, so let's go ahead and take a look at some examples on how to do multiply and divide polynomials. So let me start by doing. The nice thing about all of these problems is going to be we're going to leverage everything we did in the previous section. So let's see, we have 7 plus 20x minus 3x squared divided by 2x squared minus 11x minus 21. Okay, so I'm dividing these two polynomials, and the problem will say simplify. Okay, so you can clearly see we are simplifying irrational expression because you have a polynomial on the top and polynomial on the bottom. So what do? We basically cancel the common factor. So the first thing we'll have to do is we'll have to factor each of these polynomials, and then we cancel the common factors from the top and bottom. So let's go ahead and do that. Let's do that on the side. So let me first of all rewrite this top polynomial in the order of decreasing exponents. Always do all your factoring with these problems on the side because they're going to get complicated, so it's better to do them on the side. Now, we cannot have a leading coefficient be negative. We've talked about that, so I'm going to take out a negative 1 from all of these. So I get 3x squared plus minus 20x minus 7. anytime you take out a negative 1 out of all the terms, you're basically dividing each term by negative 1. Or you can think of it as just flipping all the signs. This negative becomes a positive, this positive becomes a negative, and so on. So now let's factor this. There's nothing common here, so we use the AC method. So I get 3x on the top. I get 3x over 3. Okay. I want two numbers. When I multiply, I get 3 times negative 7, which is negative 21. And when I add, I get negative 20. So you can play with numbers in your head to do this, or you can just do them very quickly. You'll end up with negative 21 plus 1. Okay, so what's common in these two terms on the top? There's a 3 common, so I get x minus 7. I get 3x plus 1 divided by 3. The 3's cancel, so I get minus 1 times x minus 7, 3x plus 1. So those are my factors that go on the top. Minus 1 times x minus 7 and 3x plus 1. So when they ask you to simplify this is a rational expression which looks very complicated. In essence, you're dividing one polynomial with another. So the best thing we can do is to make it simple, to make it easy. We're going to try to factor it, so that way we can create multiplication, which is what factoring lets you do, and then we can cancel anything that's common on the top and the bottom, the same factors on the top and the bottom. So now let's factor the bottom, and again you're going to have to do that on the side. So we have 2x squared minus 11x minus 21. 3 terms, nothing in common, degree 2, so we AC method. So I have 2x, I have 2x over 2. I want two numbers. When I multiply, I get 2 times negative 21 is negative 42. And when I add, I get negative 11. Okay, so I want to find two numbers that behave that way, that gives us negative 11 and negative 42. So the numbers are what? Negative 14 and positive 3. So you get negative 14 and positive 3. Okay, so I can take out a 2 from the top. I get x minus 7. I get 2x plus 3 divided by 2. The 2's cancel, so those are my factors. So I get x minus 7 and 2x plus 3. Now that I've created multiplication, I can cancel these. I get minus 1 times 3x plus 1 divided by 2x plus 3. So there is your solution to that problem. Okay. At this stage we're going to stop here, but later on in this class, in another chapter, we're going to learn how to divide this further. But for now, we'll stop here. They've just asked us to simplify. So when they ask us to simplify something like this, we just basically factor everything, because we need to create multiplication, and factoring is the only thing that lets you do that. Once we create that multiplication, we can cancel the things from the top and the bottom, because factoring lets you write something as a product. Once you write it as a product, you can cancel the common factors. Okay, let's take a look at another example, and you can see these problems do get long, because it's just a lot of work to do the factoring. Okay, so let's say if you have x squared minus 4 divided by x squared plus 2x minus 8 multiplied by x squared minus 11x plus 28 times x squared minus 5x minus 14. So this time I'm multiplying two rational expressions. It's not any different than what I just did a minute ago. We just need to factor everything and cancel the common factors. That's what we need to do. We just need to factor everything and cancel the common factors. So let's go ahead and do that. So I'll have to do all of that on the side. The first thing is I have x squared minus 4, two terms, nothing in common. You have to use a formula. Since it is a 4, we want to write it as x squared minus 2 squared. So we get x minus 2 and x plus 2, products of conjugates. So we get x minus 2 and x plus 2. And I know I'm going through this fast, but we spent a whole section, the last section, on factoring, and if you did your homework, you should be very fluid with this. The next thing we want to do is we have x squared plus 2x minus 8, nothing in common, degree 2, AC method. We have x, two terms. When I multiply, I get -8, and when I add, I get 2. So we get -4 and +2. So we get x plus 4 and x minus 2. Do the same thing here. X squared minus 11x plus 28. Okay, so we get x AC method, nothing in common, nothing on the bottom to go because it's 1 on the front. We get two numbers. When we multiply, we get 28. When we add, we get -11. So they're -7 and -4. So we get x minus 7 and x minus 4. And we have x squared minus 5x minus 14. 3 terms, nothing in common, degree 2, AC method. So we get -7 and +2. We want two numbers that multiply to -14, add to -5. X minus 7 and x plus 2. Now that we've created multiplication everywhere, we can cancel things. Please do not do that. Cancel this, because there's a subtraction and addition in the middle. You cannot do that. You can only cancel when you have multiplication. So now I have x minus 2, x minus 2. I can cancel that from the top and the bottom. X plus 2, x plus 2. I can cancel them. Doesn't matter where it is on the top and the bottom. It just needs to be on the top and the bottom. I can cancel the x minus 7 and x minus 7. And that's about it. So I'm left with x minus 4 over x plus 4. There's your answer. So you can see we simplified this quite a bit. The problem would have said simplify. Look at what we started with, look at what we ended with. So this expression that I started with is exactly the same as this one. Okay, so just keep that in mind. When you're factoring, when you're working with rational expressions, and the first thing you should always do is factor and see if something's cancelled. If they do, just cancel them up, and then you'll end up with something really simple. Okay, let me do one last example that involves division. So let's say if you have 2x minus 6 divided by 6x squared minus 15x, divide that by 4x squared minus 12x divided by 18x cubed minus 45x squared. So let's take a look at this. Again, it's a rational expression. They've asked us to simplify. Make this simple because a lot of things happening here. So the key thing is different about this one than the last one is you have a division. So the first thing I need to do is change the division to multiplication, and I need to flip that second fraction. Okay, but before I do all of that, I need to factor all of this. So let's start with 2x minus 6. What's common in them? 2. So I get x minus 3. So I factored that. Then I factor the next one. I have 6x squared minus 15x. What's common in these two terms? There's a 3x common. So I'm left with 2x minus 5. So I'm left with 3x times 2x minus 5. Over here I'm left with, I have 4x squared minus 12x. So there's a 4x common. So I'm left with x minus 3. And these are easy to do because there's nothing else you can do once you take out the 4x. You can't break these down further. Okay. Then I have 18x cubed minus 45x squared. There's a 9x squared common, so I'm left with 2x minus 5. Okay. And I forgot to flip these, so let me do that. 4x x minus 3. And then you have 9x squared times x minus 5. I had to flip these, remember that? So I need to do that. So I factored this and put the factors down here, and I factored this and put them on the top. Now we can cancel things from the top and the bottom because you have multiplication everywhere. Okay, so let's start with things. Oops, there should be a 2. 2x minus 5, 2x minus 5, they cancel. X minus 3 and x minus 3 cancels. There is a 2 here and a 4 here, so 2 goes into 2 once and 4 2 times. 3 goes into 3 once and 3 goes into 9 3 times. There's an x times x is x squared, so that'll cancel these. Because you have x times x is x squared, you have an x squared on the bottom. Okay, I mean on the top. So the answer is what? Everything is gone except for the 3 on the top, and everything is gone except for the 2 on the bottom. So you have to appreciate the math that we just did, because this problem, which looked really messy and ugly, is the same thing as this one. So that is kind of nice. When we simplify, we really crunch it down quite a bit. So when you're multiplying and dividing rational expressions, all you have to do is just factor them, create the product, and then just cancel the things from the top and the bottom. The next thing we want to do is with rational expressions is we want to add and subtract. We want to add and subtract rational expressions. So this is again very similar to adding and subtracting fractions. What's a key to adding and subtracting fractions? We need a common denominator. So we need a common denominator. So when you're adding and subtracting fractions, we need a common denominator. Similarly out here, we need a common denominator. Now to find the common denominator, what do we do? So let me talk about that. To find, I'll abbreviate common denominator CD. You do two things. Factor the denominator. Okay. And the second thing is you once you factor the denominator, then you take each factor to the highest power, and that's your common denominator. Let me give you that with numbers first, show you that with regular numbers. Okay, let me just do an example with numbers so you guys can see. Let's say if I have 5 over 12 minus 7 over, let's say, 18. Okay, now I want to find the common denominator. The first thing I do is take each denominator and factor it. So 12 is what? 2 times 2 times 3. I can write it as what? 2 squared times 3. 18 can be written as what? I can write it as 2 times 3 times 3. So I get 2 times 3 squared. So what is my common denominator then? What did I say? Take each factor. I have two factors, 2 and 3. So take each factor to the highest power. The highest power of 2 is 2 here and 1. So the highest power is 2. And the highest power of 3 is 2. So my common denominator is 2 squared is 4. 3 squared is 9. So my common denominator is 36. Okay, so then what do I want to do? I want to make this 36 and make this 36, right? So I'm going to multiply at the top and the bottom by something to make that 12 36. In this case, it's 3. So you get 3 over 3 times 15 over 12. And then over here, 18, I'm going to multiply by 2. 2 times 18 is 36, so I have to do the top to negate that. So I get 45 on the top over 36, minus I get 14 over 36. Now they have the same denominator, so I can write them as 1. So I get 45 minus 14. Okay, so it's 31 over 36. So that's how we do with numbers, and we're going to do exactly the same thing with polynomials. There's going to be absolutely no difference. So let's take a look at it. And the problem will basically say simplify. Because over here, think about it, when it said simplify right away, what did we want to do? Add them up, right? Make them nice looking one fraction as opposed to two separate fractions. That's what we want to do here. So let's say if I give you something like this, if you have 3x plus 2 divided by x squared minus x minus 12 minus x over x squared plus 8x plus 15. Okay, So I want to simplify these. I want to add these two fractions. Just take a minute and look at the problem first. I have a fraction here, a rational expression, and another one. I'm subtracting them. So what do I want to do? Add them up. Anytime you add and subtract fractions, we need a common denominator. So let's find that. How do? We factor the denominators first. So let's do that. Okay, so we have 3x plus 2. You can go on the side and factor this. So you have x squared minus x minus 12. 3 terms, degree 2, nothing in common. You get x. So you get negative 4 and positive 3. So we get x minus 4 and x plus 3 minus, I have x on the top here. I do the same thing with this, and just for the sake of time and writing, I'll factor this for you. You get x squared plus 5 and x plus 3. But you should do that factoring on the side. Just draw a line and do the factoring on the side. So now that we factored it, I want to find the common denominator. How do I find the common denominator? My common denominator, how do you do that? What did we say earlier? Take each factor, so start with this, to the highest power. The highest power of x minus 4 is 1. There's no x minus 4 here, so it's x minus 4. The highest power of x plus 3 is what? 1. So the highest power is just 1. And the highest power of x plus 5 is also just 1. So there's my common denominator. So now I want to make this denominator that I have look like this. So what am I missing if you compare these two? I have an x minus 4 and x plus 3. I have that. I'm missing an x plus 5. So I'm going to multiply the top and the bottom by x plus 5 to negate that. And on the top I'll put parentheses, so please make sure you guys do that because there's two terms here and I'm going to multiply. Minus, I have x. What is this denominator missing? I have x plus 5 and x plus 3. I have these two. I'm missing an x minus 4, so I'm going to multiply and divide by x minus 4. So there we go. Now, what do we do? Well, these two denominators are exactly the same, so let's write them as 1. And on the top, we'll have to distribute and clean up. There's work to be done. So let's distribute this. So we get 3x squared plus 2x. Distribute the 5. So we get plus 15x plus 10. Over here, we'll distribute the x. But there's a negative in the front, so please do not forget that negative. So it's actually minus x. So you get negative x squared plus 4x. So if I distribute, what do I get now? After I distribute, I can collect the terms as an x squared term. So 3x squared minus x squared is 2x squared. Then I have the x terms here. I have 2 plus 15 is 17x, plus 4 is plus 21x, plus 10, divided by this. Now, at this stage, you might think, okay, I'm done, because there is a degree 2 problem on the top with 3 terms. I should try to use the AC method and factor that. You'll find out that you cannot do it, but you should at least try, because sometimes you can factor it and then you can also cancel something else there. But in this case, we cannot factor it, so there's your answer. Okay, so when you're doing these problems, when you're adding and subtracting fractions, you're really doing what we did with numbers. We're not doing anything new. We're just using the same ideas that we used when we worked with numbers. We're just basically extending them to rational polynomials. So let me go ahead and do one more example of this so you guys can get a little bit more practice. So let's say if you have 2x over x squared minus 9 minus 1 over x plus 3 plus minus 2 over x minus 3. Let's take a minute and look at it. The problem might just say simplify, and the reason why it's saying simplify is because you can see I have 3 fractions. I just need to add them all up together. That's why it's going to say simplify. Okay. Or sometimes it could say perform the indicated operation, where you have subtractions, you just want to subtract these polynomials. Okay, so sometimes it might say perform the indicated operation. So the first thing we need to do is whenever you add or subtract fractions, we need a common denominator. So before I can find the common denominator, I need to factor this. So let's do that. I can just do that on the side. You have x squared minus 9. You have x squared minus 3 squared. So you get x minus 3n, x plus 3. So I'm just going to go ahead and replace it right here. I can erase it and put that in, x minus 3n, x plus 3. So now I need my common denominator. So let's do that. What's my common denominator here? I have x minus 3. I take each factor to the highest power. I have x minus 3, highest power is 1, 1. And then x plus 3, the highest power is also 1. So that's my common denominator. I want each of these denominators to look like this. The first one already does, so there's nothing to do there because I have the same thing as my common denominator. The second one, I'm going to have to multiply the top and the bottom by what? X minus 3n, x minus 3. And the third one, I'll have to multiply the top and the bottom by x plus 3 and x plus 3. Okay. And I'm doing both the top and the bottom to negate it. I can't just introduce something into the problem without offsetting that. So my common denominator is this. Since all of them have the same denominator, I can write them as 1. On the top I have 2x here. Out here you distribute the 1, but keep in mind again, you are distributing negative 1. Don't forget those negative signs. So you get negative x plus 3. Out here you're distributing a negative 2. You guys can see that. So you get negative 2x minus 6. So the 2x's cancel, they're the same. So I get minus x minus 3 over x minus 3n, x plus 3. Okay, so I added them together. Now, what's going to happen over here? What do you notice? Remember what I said in the previous problem. If you can factor the top, you should always try to factor the top. So always remember that. So just don't get complacent and say, oh, I'm done. No. If you notice, one of the rules you always follow is that you don't want the leading coefficient to be negative. So let me take out a negative 1. So whatever I take out, you divide each term by that. So negative x divided by minus 1 is just x. Negative 3 divided by minus 1 is positive 3. Since I have multiplication, I can cancel. This will cancel this. So my answer is this, minus 1 over x minus 3. So you can see how we did that. So please make sure you guys take a few minutes and do these problems because they're not difficult. They're just extending the ideas of adding and subtracting fractions. One last example before we quit this section. Okay. So let's say if you have 4 over y plus 2 minus 1 over y plus 1. Okay. I want to add these fractions. This is technically over 1. So I need to find the common denominator. This is already factored. They cannot be factored any further. That is. So my common denominator is what? Take each factor to the highest power. So I just get y plus 2. And the highest power of this is just y. That's my common denominator. I want to make each of these look like that. So I'm going to multiply the first one by y. I'm going to multiply the second one by y plus 2. And then the third one, I'm going to multiply by both y and y plus 2 because I'm missing both of those things. Now that I did that, you notice I have the same denominator across the board. So I'll just write them as 1. And I'll multiply these two, so I get 4y. I'll distribute the 1. Again, it's actually a negative 1, so don't forget those negatives. Minus y minus 2. And out here I'll distribute the y and multiply by 1, so you just get plus y squared plus 2y. So what do we end up with? Well, let's clean it up. Y squared, I can add these guys, 3y. Add this, so I get plus 5y minus 2 divided by this. So that's what we end up with. This is degree 2 with 3 terms, so I should try to factor it, but you'll notice you cannot. And if you remember in the last section, I showed you how to check that by finding the discriminant, right? Do you guys remember that? If you're not sure if you can factor the top, you can just find the discriminant. B is 5, so you get 5 squared minus 4 times A times C. C is negative 2. So you get 25 plus 8, so you end up with 33. Is 33 a perfect square? No. So that tells me that that cannot be factored, so we are done. So that's how we factor those problems. Okay, I'm sorry, that's how we solve those problems. I'm sorry. Make sure you guys do your homework so you get a better understanding on rational expressions. All they are fractions, and if you're multiplying and dividing them, just factor them and cancel the common factors from the top and bottom. If you're adding and subtracting them, make sure you find a common denominator and add them just like you do with numbers.